Hello everybody, welcome to Learn Then Teach. This channel is pretty much centered around me learning things and then me recording me doing these things and teaching them to you, the viewer. The whole point is, alright, when you learn something, you know you really internalize that information when you can then go and teach somebody else, right? So that's my goal. I'm going to take what I learn and then I'm going to teach it so that I have a better understanding of what it is I learned, if that makes sense. Okay, so basically this series is going to be looking at a previously made little series of tutorials on assembly made by a dude known as Lena or Lena. I'm not really sure how to pronounce that. And basically in this little series of his, he walks you through learning assembly with the use of a program known as OllyDbg, which is a Ring 3. It's a Ring 3 application, or a Ring 3 debugger, and basically that means it runs, or it works at the Windows application level, but it can control other applications, or look at how other applications work, if that makes sense. And so basically I'm going to be taking his 40-part series, which are it's like a no audio text tutorial. It's pretty much what he uses, and I'm gonna be basically adding my voice to those series, because I know some people they learn better when they have somebody speaking out loud as opposed to just reading text off a screen. And Lena's approach is very, very good, because it's way easier to learn something in a practical setting where you have some hands-on experience, as opposed to just sitting there and watching a bunch of slides, right? So without further ado, I'm going to go ahead and jump into OllyDbg here. Wow, that was really loud. Close that. Alright, so this is what Olly looks like. And as far as what all these little windows are, we have this is like our memory pane. This is where we're going to be looking at the program's instructions, and you'll see that in a second when we load up our little reverse me program. Our registers are going to be found here, our 32-bit registers, EAX, all that stuff. This is our hex dump, which we won't really be using too much in this first tutorial. And then down in the bottom right is where we can find the stack. Okay, so basically what we're going to be doing today is reversing this executable, which when run says that key file reverse me, and it says evaluation period out of date, purchase new license, and when we go ahead and hit OK, it just exits the program. So what we're going to be doing in OllyDbg is we're going to be getting around that little pop-up, and then when you do finally crack the program, there's a little pop-up that says, oh, congrats, you did it. So basically that's what we're going to be trying to get to. So if we go back to OllyDbg and we open that reverse me file, here you can see all these little windows become populated with stuff, and at first it's really intimidating to look at, but it's actually not that bad. So here you can see the virtual addresses, like I said before, and these are pretty much the addresses of where the program was loaded into memory. It's not always the same, it can change. And so in this next column, you can see that we have our opcodes, and opcodes are pretty much what the computer interprets from these mnemonics here. So the computer doesn't actually take these and execute, right? This column is just so we as humans can understand what's going on. This is what the computer is actually going to read, right? So these opcodes are going to be fed into our CPU, and then it's going to decide what to do based off those opcodes, right? So this is pretty much a translation. This whole column is a translation of this whole column. Okay? Okay. And so this column here is sort of like a comment section for Olly. It'll tell you like what's contained at certain addresses. Sometimes it's pretty hit or miss. Sometimes you can see stuff there, and if we actually scroll through the program, you can see that message that I was talking about. This is the message that we want. See, key file reverse me. You really did it. Congrats. So that's what we're going to be trying to get to in this tutorial. And you see we also have other messages like evaluation period, out of date, purchase new license, and that's the pop-up that we saw first when we actually open the program. And this pop-up is what stops us from getting to that pop-up that we wanted to get to. So we're going to be trying to go around that. And then we also have this pop-up where it says key file is not valid, which we won't really be. Well, this is pretty much just another check, right? It's another internal check that the program is going to use to verify whether or not we have a key file and we're registered and stuff. And basically, we're going to be trying to get around that too. So we're going to get around this one and this one. That's our goal. Okay, so basically, our instruction pointer, our EIP here that you can see 0040100, that is this is always, the EIP is always going to be on the entry point of the program. So it's going to be where the program starts in memory, basically. So this push 0 and onward, this push 0 is the entry point. And so that's where it's always going to start. If we were to close this and then reopen reverse me, it's going to start at the same place because that's our entry point, right? Simple enough. Okay, now what we're going to want to do is we're going to want to step through this program. And stepping through the program basically means this. We're going to go line by line and look at these instructions line by line. And we're just going to keep going down because the program executes from top to bottom, right? So if I were to go all the way down, if I keep stepping down, it's gonna load all these instructions and whatever. And you see, basically it's gonna push an ASCII value onto the stack, which happens to be the title of that pop-up window that we first seen. So if I keep stepping down, you'll see right here, you'll see that pop up again, right? And when you hit OK, the next instruction is to exit the process. So that pretty much closes the program, and that's not what we want. So to go back to the entry point, you just hit this restart little button here, and it takes you back up to the top so we can re-step through the program. So now this time we're going to step through the program, but we're going to make changes along the way so that we can avoid those bad messages that we don't want to pop up. So step through the program here. This calls get module handle A, and that's basically a Windows API function. So if we were to go ahead and look that up on Google, you'll see that we have get module handle A, right? So we go in and see what that does. It retrieves a module handle for the specified module. The module must have been loaded by the calling process, and that's exactly what happened, right? So that's not necessarily important for our overall goal, right? We're just going to keep stepping down, and these are all values that are being loaded that are necessary for the program to run. See, we got load icon, load cursor, and we have our create file, which is going to create a file. If we actually, let's look that up too, so you can see. It's always good to see what these Windows API functions do so that you get a better understanding of how the overall program flow works, right? So a create file function that's being executed here from the kernel, which is where the kernel is basically where all the Windows API functions are found. And so the create file function, what that does is it creates or opens a file or an input-output device. The most commonly used input-output devices are as follows: file, file stream, directory, physical disk, volume, console buffer, tape drive, communications resource, mail slot, and pipe. And you can see the arguments. We have a file name, we have our desired address where we want that to be loaded in, and we have a bunch of other stuff which isn't really necessary at the moment. This is where things really get kicked off in terms of verifying whether or not we have a valid key in our program, right? So as you can see here, we have create file A. And what create file A is basically doing in terms of this program is it's saying, okay, does this file exist? Does keyfile.dat exist in my current directory, right? And basically this function, it's going to return a value. And then we're going to compare for that value here in these next two instructions. Okay, so this compare is basically going to say, well, let's look at the structure of the entire program first, right? Just so we get an idea of what exactly is going on at every stage in this program. So this is what we're going to do. We're just going to go into our notepad here, and we're just going to comment what actually happens in terms of execution in this program. So basically what's going to happen is we're going to double click the program, and that's going to start it, right? And then, okay, once we start the program, we're going to start loading all our necessary, files and functions and stuff. You see, we load a module handle, we load an icon, which is like, this little icon right here for the program, and then we load our cursor, so we can get cursor coordinates within the window so we see what we're doing and stuff like that. So we double click and start the program, we load important stuff. As you can see here, like I just said, this create file is checking to see if we have keyfile.dat. Right, and then we're going to jump down to this compare, and this compare is basically going to say, okay, compare the values. Let's see if we have that key file in the directory, and then if we do have that key file in the directory, then it would jump over this, right? It would set a value to where we would jump over this error message, right? So once we jump over that error message, or rather we can say this, we can say if key is there, jump over error, and then we can say if key is not there, display error. And then if we scroll down and we see what else is going on, and you see once it outputs the error, it's going to exit the process, right? So this basically means we're done. That's as far as we're going to get if we don't have that key file. So if we look past this, we can see that it's gonna read the file, and then once it reads the file, it's gonna say, okay, we're gonna jump into a loop, which you can see indicated by this little bracket right here. Okay, so we're gonna jump into a loop, and basically what this is gonna do is it's gonna verify every individual letter within that file to basically see whether or not we have a valid key. So that's how that's going to happen. So we're going to say, okay, if file is there, loop through all characters to see if key is valid. And then we have, let's see. So we're going to jump, we're going to compare these, and we're going to jump, and that takes us to this this error message. So basically if key is not valid, jump to another error message, and if key is valid, let's see, that's going to jump down outside the loop. This is going to jump into the error, and then this jump right here is going to take us to the good message, right? You really did it, congrats. So that's pretty much the program structure. If key is valid, take us to good message, and you can kind of get a sense for like what the code would look like once you do this right here. So knowing this little blueprint, we're going to go ahead and make our changes so we can get to that good message. All right. So like I said before, it all starts at this first compare here. Okay, we're going to see if the file exists. We're going to use the compare function to do that, and then we're going to use our jump to execute our desired action. So you can see at the moment the jump is currently not being taken, right? Because when a jump gets taken in OllyDbg, you can see that this little flow arrow, it'll turn red to let you know that we're going to take the jump. Okay. So this compare, what's going to happen is this compare is going to modify what's known as a Z flag, which you can see right here, Z in the 1, and that's basically our condition, right? So if it's 1, they're equal, and if it's 0, they're not equal. And so basically what this is going to say is, okay, -1, which is the value we want to compare to the value of EAX, which also happens to be -1, is going to say, okay, these values are equal. But you can see the condition for this jump statement is jump if they're not equal, so it will never jump because those two values don't equal each other. So what we have to do is step down into this jump function, and what we're going to do is we're going to modify that Z flag that was set from this compare instruction, right? So we're going to say double click, and then you can see, like I said before, that actually turns red, and what that's going to allow us to do is jump right over this error message. So if we step down again, you can see we jump right over that, and we don't get the pop-up anymore. So if we go back into our little blueprint, we can say, okay, we took care of all this already, right? And I'll mark that with a hyphen, just to know that we don't have to deal with that anymore. Or rather, I'll do it like this. I'll just set the font smaller. That didn't do what I wanted it to do, but you get my point. So just make that bigger so you can see that. All right. So now what is our next step? Okay, if the key file is there, loop through all the characters, see if the key is valid. So now we're going to tackle this loop. And we're going to step down, keep stepping down. And then you see we have another jump here, which jumps over another jump instruction. So where does this jump instruction take us? This one takes us to an error message. So what we want to do essentially is, okay, this jump is currently not being taken, but due to the fact that it's not being taken, that means that we're going to run into this jump right here, and this jump is going to send us to the error message, and that's not what we want. So what we're going to do is we're going to step into this first jump. You can see OllyDbg is telling us a jump is not going to be taken. So what we want to do here is pretty much the same thing we did to avoid the first error message. We want to mess with that 0 flag. So if we go ahead and do that, you can see, boom, okay, the jump is going to be taken, so we're going to completely avoid this one that sends us to the error message. So we can step down, and it'll take us right over that. And then right after we do that, we now are getting ready for our loop. So you can see our XOR EBX. When you have this XOR instruction and you have a register and then the same register, what that's going to do is it's basically going to zero that out, right? So if you can see over here in our registers section, you can see that EBX, if I were to step down, EBX would get reset to 0. And same for ESI. So if I should do that now, you can see EBX just got zeroed out. And then once I step down again, our ESI is also going to get zeroed out. So if I do that, you can see, boom, ESI is zeroed out and our EBX is zeroed out. And so the next thing that's going to happen is another compare, and then that compare is going to set us up for another jump. So we can see that we're comparing the value 10 to the value that is stored at this address in memory. You can see we're using the dereference operators around that address. This basically means we're going to get the value of that memory address and not the actual memory address. So whatever is in there, and we can actually see that the current value of that memory address is 0. So we're comparing 10 to 0. Alright, so we're comparing 10 to 0, and then our next jump instruction is, okay, it's going to say jump if less than. And if we step down into that jump, we can see that this jump is currently being taken. And that's not good, because what that's going to do is jump us into an error message. And that's not what we want. We want to completely avoid that, actually. So in order for us to make it into the next verification step of the program, which is where it loops through all the characters, what we need to do is make sure that we take care of this jump first, because if we don't, then we're just going to go boom straight into the key file is not valid message. So what we do here is when you have, since we have a jump and less than, which is different than the jump if not equal to's that we've been messing with. The jump if not equal to instructions usually look at the 0 flag specifically to make their decision. Now when we're working with a jump then less than, or a jump if less than, or a jump if not greater or equal, we're looking usually at the S flag here. You can see it's right under that 0 flag. So now that S flag is going to allow us to manipulate what this jump does. So if we go ahead and we double click that 1, you can see that boom, we just nullified the jump. It's not going to happen. So when we next time we step, we're going to step into this loop here as opposed to just jumping straight into that error message. So let's go ahead and do that now, and boom, we're in the loop. So you can see we're just allocating some data from this offset here, from our EBX 0 plus this address, and we're dereferencing that. So we're getting the value and we're moving that into an actual 8-bit register, which is what this AL is here. And then if we step down one more time, we see, okay, we have a comparison going on. It's comparing 0 to whatever value we have in this 8-bit register, and you can see we're comparing 0, and you can see that 8-bit register is also 0. So currently these two are equal to each other, and that's the condition that this next jump is looking for. So if we step down, you can see it's going to get taken because those two values are equal. And what this next jump is going to do is it's going to jump us out of the loop, and we're going to jump into another comparison. And this comparison is looking at jumping if less than. So if we click that jump, we can see that what's going to happen is we're going to get jumped into the error message again, which is not what we want to do. And you can also see we have another jump here. And what this jump is going to do is it's going to boom. It's going to take us all the way to what we want, to where it says, you really did it. Congrats. That's where we want to go. We don't want to go back into this error. So what we're going to have to do is, okay, this is our current instruction. So we can take this jump, right? Because basically what we can do is if we take this jump, it's going to set us up to modify this jump so that we completely ignore that, and then we just step down to this jump, which will take us to the message that we want. Okay, so now what we want to do is the same we did with the other jump if not equal. We're going to be modifying our Z flag here so that we can, or actually, no. We're not going to be touching this jump at all. We want to take this jump. Okay, so we're going to step down. Boom, we took the jump. So we didn't touch that first one there. And the one we actually want to modify is this next jump after this compare. So step down into that next jump, and what we want to do is, you can see it's another jump if less than, right? So what we're going to be doing is modifying the S flag, not the Z flag. So we're going to go ahead and do that. Change that 1 to 0. You can see that's going to nullify that jump. We can step down, and then if we happen to step down again, it's going to step us down into the section that we want to be in. So now if I just keep stepping down, we're going to get our pop-up that says, congrats, you really did it. And that's pretty much it.